dear students, how are you? Hope you are doing very well. Today inshallah our lesson will be about forces. Okay, so first of all, what is a force and how does it act on an object? So guys, you have probably heard the word force used in conversation, like people usually say do not force the issue and so on. So after scientists also use the word force. So what exactly is force and how it is used in science? So in science, a force is a push or a pull, and guys, it's very important to know that all forces are vectors. What do we mean by vectors? You maybe remember that we explained this word in our previous lesson when we discussed about acceleration, and we say that acceleration is speed that has a direction. Okay, so guys, all forces, as I said, are vectors, which means that they have both a size and a direction. Okay, so force may be exerted upward or downward or to the left or to the right and so on. Okay, so what is the unit that we use to express force, guys? The unit is Newton, and usually we represent it with this symbol, capital N letter. Okay, so guys, actually forces exist only when there is an object for them to act on. However, guys, forces do not always cause an object to move. Like when you sit in a chair, the chair doesn't move. Why? Because your downward force on the chair is balanced by the upward force from the floor. So forces do not always cause motion, and we're gonna explain this point later in this lesson with more details. So guys, here we have two different types of forces. Draw arrows to represent the pushing forces in the image at left and the pulling forces in the image at right. So here at left we have what? We have a pushing force. So let us try to draw the arrow. It will be this direction, since we said forces are vectors. So as we said, we need to consider the direction of the force as, or in addition to the size of this force. Okay, so it will be this way. What about, guys, the image at right? Here, as you can see, we have pulling forces. So actually we have two pulling forces. Maybe the dog is pulling to the left, and maybe this lady is pulling this object to the other side. You may add two arrows, or you may just add one arrow for to represent the pulling force of this dog. Okay, so I'm gonna add one force. It will be this way. Okay, if you want to add another arrow to represent the pulling force that is exerted by this one, it will be this one, guys. Okay, so it will be in the other direction, the opposite direction. Okay, so this is two pulling forces, and we have here like one pushing force. Okay, pulling force can either act directly on an object, or it can act on an object from a distance. So forces can act on objects that are in contact with each other, as I said. Such a force is called what? A contact force. So force that is acting directly in an object is called a contact force. An example of a contact force, guys, is friction. Friction is a very important type of force. Friction is an example of contact force between two surfaces that are touching. Okay, and actually, guys, what do we mean by friction? Friction is the resistance to motion of one object moving relative to another. Like if certain object is moving this way, another force will affect and will be exerted on this object, but it will be in the opposite direction of its moving. And guys, as we said, friction is very important. Why? As you can see here, car tires rely on friction to keep a moving car from sliding off a road. Cars may slide on icy roads because ice lowers the force of friction on the tires. So friction usually, guys, stabilize our motion and prevent us from falling down, okay, while we are walking. Okay, so as we said, forces can also act on objects that are at a distance. Important, guys, examples for forces that act at a distance: gravity. Gravity is a force that pulls objects toward Earth, and I think you all guys familiar with this type of forces. Later, inshallah, we'll talk about it in more details. Guys, another example, the magnetic force. Magnetic forces can also act at a distance. Magnetic force can be a pull, as when a magnet holds paper to a metal refrigerator door, or a push, as when like poles of two magnets push each other apart. Okay, so gravity and magnetic force, both of them are examples of forces that act on an object at a distance. Okay, so guys, here in this image we have different objects. Okay, and each object, as you can see here, certain forces will be exerted on these objects. So the question is, the arrows in the picture below represent contact and distance forces. As we said, contact forces is a force that is acting on objects that are touching, while distance forces are forces that act on objects at a distance. Okay, so label each arrow with a C if it is a contact force, or D if it is a distance force. So guys, let us start with this arrow here. Guys, what do you think? Force is pulling this airplane downward is what this is a distance force. Okay, so this the gravity actually is affecting and exerting a force at this object, this airplane, but here the force is acting on this object at a distance. Okay, since there is no they are not touching. Okay, so what about this arrow, guys? What do you think? C or D, contact or distance force? Exactly, this is distance force as well. What about, guys, here? This boy is pushing the lawnmower. Okay, so here, guys, it is what? Exactly a contact force, since the boy is touching the lawnmower. What about, guys, this arrow here? Yes, it's a contact force, the force between the ground here and this boy. Okay, so guys, this is a contact force. So guys, an important question: what happens when multiple forces act on an object? A very important question. The net force is what is the combination of all the forces acting on an object. So let us see, guys, these forces, how it will affect this object. Okay, so guys, let us consider the following example. Suppose we have this object. Okay, so now when forces act in the same direction, they are added to determine net forces. So suppose here we have different forces that are acting on this object. One force is exerted on this object in this direction. Okay, the other force, okay, suppose it will act on this object, but from the opposite direction, this way. So guys, as you can see here, now we have two forces acting on this object. As we can see, the length of the arrows are equal, which means that the forces are equal. Okay, but the direction of forces are what? Different. They are acting opposite to each other. Okay, so as we said, when forces act in the same direction, they are added to determine the net force. So now let us put both of the forces in the same direction. Okay, this way. So guys, suppose that amount of this force is equal to 5 Newton, for example. Okay, so it's 5 Newton. Okay, capital N. This is for the first force. What about the second? For example, let us say amount of this force is equal to 3. Okay, so amount of the second force is 3 in Newton. So guys, now the net force, as we said, if the forces are in the same direction, and okay, they are added to determine net forces. Okay, so net forces here in this case will be equal to what? 8. Okay, so guys, the equation will be as following: net force equal 5 Newton, so 5 Newton plus 3 Newton, and equal 8 Newton. Okay, so net force that will affect, or that will act on this object, is equal to what? 8 Newton. Okay, so guys, this is for, or this is when both forces are acting on the object in the same direction. But suppose the forces are acting on this object in different directions. So here, guys, when forces act in opposite directions, the smaller force is subtracted from the larger force. Okay, so guys, 3 Newton, the length of the star should be smaller. Okay, so now again, let us assume that we have two forces acting on this object. The first one will act in this direction. The other force will act in opposite direction. Well, okay. This way. So suppose this force is equal to, for example, 10 Newton. Okay, so 10 Newton. This one is equal to, for example, 4. Now let us say 5 Newton. Okay, I'm gonna just try to make it longer a little bit this way. Okay, it's almost the half of this arrow. So 5 Newton for this force. So again, as we said, we have two forces acting on this object, but in opposite directions. So here, net force. To get net force, you need to subtract the smaller force from the larger force. Okay, so again, guys, the equation will be as following. Okay, here, net force that will act on this object is equal to 10 Newton minus 5 Newton. So as we say, the smaller force is subtracted from the larger force, and the answer, final answer, will be 5 Newton. Okay, so guys, this is how we can calculate a net force for multiple forces that is acting on an object. Okay, so now, guys, a net force of 0 means the forces are balanced and will not cause a change in motion. So if we got 0 here, guys, then this means that this object will not move. Okay, and here we can say that forces are balanced. Like example for that, guys, again, suppose we have this object and you want to move it. Okay, now we have two forces that are acting on this object. Okay, this is the first one, and this is the second one. Okay, this one will be acting in this direction, and guys, I will make the length of these two arrows equal. Okay, which means that forces are balanced. So this force equal to, okay, 2 Newton, for example. Okay, the same is for this force. Okay, so this one also has a value equal to to 2 Newton. Okay, 2 Newton. So forces are balanced, means that forces are equal, as we can see here from the length of the arrows and from the value of these forces. Okay, 2 Newton for both forces, but they are guys, as we can see, they are acting in opposite directions. So now if we want to calculate a net force for these two forces that are acting on this object, again the equation will be, as we said, for forces that are acting in opposite direction, we need to subtract one force from the another. So 2 minus 2 equal to what? To 0. So in this example, the net force is equal to what? Net force is equal to 0, which means that this object is not moving. Okay, so let me write the equation here for you, so you will not forget. We calculated it. Okay, so guys, net force is equal to 2 Newton minus 2 Newton equal to 0. 0 Newton means that this object will not move. Okay, so unbalanced forces produce a change in an object's motion. Unbalanced forces means that these forces are not equal, like the one here. So here we have unbalanced forces acting in opposite to each other. Here also we have unbalanced forces. They are not equal and they are acting in the same direction. So again, guys, balanced forces means that these forces are equal to each other. Unbalanced forces means that these forces are what? These forces are not equal to each other. Okay, so guys, again, unbalanced forces produce a change in object's motion because the net force will not be equal to 0, as we saw here. Okay, the object could change speed, direction, or both. This change in motion is called an acceleration, and we already discussed about acceleration in the previous lesson. Acceleration is always in the direction of the net force. This point, guys, is very important. Again, acceleration is always in the direction of the net force. Guys, for example, here, this object will accelerate or will move in which direction? To the left here or to the right? What do you think? Exactly, it will move to the, as we said, to the direction of the net force, which is the right direction. So the final, guys, direction will be this way. Okay, this object will move this direction, and here, guys, n is equal to what? The net force is equal to 8. Okay, this is the net force that is acting on this object, and the arrow should has this length that is equal to 8 centimeter, for example. Okay, so what about this one, guys? As we saw, we have here two forces that is or that are acting in opposite direction. Okay, so now what do you think? This object is gonna move to the right or to the left? What do you think? Exactly, this object is gonna move to the right, guys. Okay, because here this force is greater than this one. Okay, so it will be pushed where? To the right. Okay, so the net force will have this direction. Okay, to the right, and it will have as I say, a value equal to 5. Okay, so 5 Newton. Here. Okay, so again guys, acceleration is always in the direction of the net force, as we said. Here, two forces acting, both of them to the right, so the net will be to the right. Okay, here we have two forces acting in a direction that is opposite to each other. Okay, so here guys, the direction or the final direction should be in the same direction of the greater force or the larger force. Okay, so now guys, this question, the arrows in the first image show that the forces on the rope are balanced. Draw arrows on the second image to show how the forces on the rope are unbalanced. So guys, what do you think? How can you draw the arrows here? I will leave it to you guys as a homework. Okay, please think about it. So guys, question number 9, calculate the net force acting on the following box, the appliance box, and use it to determine if this box will move or if this box will not move. Okay, so guys, as you can see here, we have two forces acting on this object. The first force is equal to 210 Newton, and the force here in the opposite direction is equal to 119 Newton. So what do we need to do here? As we said, the smaller force will be subtracted from the greater force. Okay, so the guys, equation will be as following: net force is equal to, as we said, the larger force 210 Newton minus the smaller force 190 Newton, which will be equal to 20 Newton. So the net force that is acting on this object is equal to 20 Newton. So guys, use, as I said, use this value to determine if the box will move. Of course, it will move because the value is not equal to 0. If the value is equal to 0, then this object will not move. Okay, but this object will move, and what do you think, in which direction guys? It will move to the right. Since this force is greater, so it will move in the same direction, okay, of this force. So guys, here we have another question, and I will leave it to you. What forces are acting on these spots? How could you determine whether the forces are balanced or unbalanced? Remember guys, balanced means that forces are equal and the net force is equal to 0. Unbalanced means that forces are not equal to each other, and here the object will move. Okay, so guys, for today you have two lessons, homework, sorry, this question and the question here in slide number 9. So that's all for today. Thank you, and see you inshallah tomorrow.